Last lesson, we talked about factor trees and prime factorization. And we did the prime factorization for 24 using a factor tree, and this is the answer that we came up with. It's right. But see all these twos? There is a way more efficient way to write these twos, and it's called an exponent. An exponent is used an awful lot in science and in math too. And what it does is whenever you have a digit multiplied by itself several times, there is a more efficient way to write that down. So if I were to use an exponent to express the prime factorization of 24, wow, that sounds impressive, doesn't it? Math words are very impressive. Instead of writing 2 times 2 times 2, I would write 2 to the power of 3. See that little tiny 3 up there? That's my exponent. 2 is my base number. That's the number that's going to be multiplied, and it's going to be multiplied 3 times itself. It is not 2 times 3. No, 2 times 3 is 6. 2 times 2 times 2 is not 6, it's 8. So 2 to the power of 3 times 3, is also 24. This is your exponent. So now you know exponents. They're not hard. When you use an exponent, this is a very common one. To the power of is how we say it, to the power of 3. Let's say you have this exponent. There are 2 ways to say that. It is 4 to the power of 2. If I were to express that, it would not be 4 times 2. It is 4 times 4. You can also say that 4 squared, because 4 times 4, if you know area, 4 times 4 could also be an area, length times width. And when you have length times width, you're describing a square. So that's where the word squared comes from, 4 squared. When we have to the power of 3, we have 3 digits being multiplied together, and that would be like finding a volume, which is length times width times height, 3 of them, which would be a cube. So you may also hear this called 2 cubed. So 2 could also be squared, 3 could also be cubed. Now I like saying to the power of, because then it doesn't matter. Like, let's say, for example, we had 3 to the power of 5. 3 to the power of 5 is the same as saying 3 times 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. 27 times 3 is some other number. That other number times 3 is some humongous number. So exponents get very big very fast. And so a lot of times we have to use a calculator to do them. Now in 5th grade, you will not see big, huge exponents like 8 to the power of 9. You won't, because we're not allowed to use calculators in 5th grade. That's not to say that that's not a legit exponent. It is. But you won't be working with exponents that are that big, because when you get exponents, you get very big, very fast. And so you have to use calculators. We will be sticking mostly with to the power of 2 or 3 or 4 or maybe 5. Like 2 to the power of 5, you can still do that in your head or calculate that easily. Okay? So a couple other things about exponents. What about if you have this? 10 to the power of 1. Well, 10 to the power of 1 means 10. It means there's only 1. 10 to the power of 1. What about this one? 9 to the power of 0. What? You might think that it's 0, right? It's not. It's 1. Any base to the power of 0 is equal to 1. Now I'm going to tell you why. but you don't have to know this. But I wondered, because I could never remember it. So for me to remember stuff, I have to understand why. So for those of you that want to know why, keep watching. If you don't want to understand why, then you can carry on to your assignment on page 95. Okay? So for those of you who want to know why, here's why. Theoretically, when we have oh, I didn't do that right. We have a multiplication equation like this. Theoretically, there is always a very silent 1 there. So 10 equals 1 times 2 times 5. Okay? Oh, that's my 6 minutes. Now, with exponents, we have that same like invisible 1. So theoretically, that's what 2 to the power of 3 looks like. So 2 to the power of 2 would look like that, right? 2 to the power of 1 looks like that. And therefore, 2 to the power of 0 looks like that. I know, isn't that weird? But that's a little thing you may want to keep under your hat. So now you know why any base to the power of 0 is equal to 1, because all of the bases are gone and you're left with that 1. I don't know, it's cool.